For example C, I want to do one that isn't linear. Now the linear ones are pretty, I think, straightforward. It's very easy to see that they are indeed inverses because they literally undo. When you start doing things with like the cube and the cube root and then the reciprocal, which is going to be our last example, it's maybe not as obvious. So this one is h is the cube root of 3x plus 2. So in terms of what does this function do? Well, it takes in an input, multiplies by 3 and adds 2, and then cube roots. So I want to undo those. So my inverse should be cube, divide by 3, then subtract 2. No, cube, subtract 2, then divide by 3. That's what it should do. All right, so let's write this with y notation instead, and then we interchange x and y and solve for y. So I get x is the cube root of 3y plus 2. So to get rid of the cube root, I'm going to cube both sides. And cubing is 1 to 1, meaning it doesn't ignore negatives, it passes a horizontal line test, and I don't have to worry about extraneous solutions, which is something we did have to worry about back when we were solving radical equations. If I squared both sides, you know, I might have something that looks like a solution but isn't. Don't have to worry here, so I can just cube both sides without having to worry about it. So 3y plus 2 equals x cubed. So I'm going to subtract 2 and divide by 3. So my inverse is x cubed minus 2 all over 3. Now if you want to write this as 1/3 x cubed minus 2/3, you may do that. Okay? We did not talk about how to graph cube roots, but I went ahead and graphed this anyway. So blue is my original function, red is my inverse. I want to point out two specific points on here. The first one is -1, -1, and the second one is 2, 2. So if I plug in -1 to this function, out comes -1. So when I interchange x and y with -1, -1, it stays the same. It's still -1, -1. Same with 2, 2. So those points are actually on both functions. All right, so that's my picture. They do, again, have that symmetry. And because those 2 points don't move, they must lie on the line of symmetry. So they lie on that y equals x line.